Welcome to Lesson 2 of Section 5. Here we're going to be solving systems of equations algebraically using substitution and elimination. Now when you're given a choice to solve a system using substitution or elimination, how do you choose which one to use? Well, I'll give you a couple of suggestions. I would use substitution if the system has an equation that is already solved for a variable, because you can just substitute that into the other equation and then solve from there. Now, if the coefficients of some variables already happen to be equal or at least opposites of each other, then you can just add or subtract the two equations together to eliminate a variable. Now, something else to keep in mind is that if the system of equations has any fractions, then using elimination would be suggested. You can always get rid of fractions by multiplying the whole equation by the LCD, but when you do substitution, there still might be a case where you have to use fractions at some point, but when you do elimination, you don't have to. So these are just a few suggestions to keep in mind when you're trying to choose which one to use. So let's look at the first example. We have to solve each system of equations using substitution or elimination. So right away, I notice that the coefficients of y are both -3. So this is nicely set up for me to use elimination. So that's what I'm going to do. So I'll write down my first equation, the second equation, and then I'll just subtract these to eliminate y. So now 2x take away 5x is -3x. The y's are going to cancel, and 18 take away 9 is equal to 9. Now to solve for x, I can just divide both sides of the equation by -3, giving me an x value of -3. So now let's plug that here to find y. So doing that, we would get 2 times -3 minus 3y equals 18. Now multiplying 2 and -3, I get -6. Now let's bring the -6 over to the right-hand side and combine that with 18 to give us -3y equals 24. Now let's divide both sides by -3 so that we can get y equaling -8. So now we can write our solution as -3, -8. And you can verify the solution by replacing x with -3 and y with -8 into both equations. Now for b, which method would you use here? Now when I look at the second equation, I notice that it's already solved for x. So this is nicely set up for substitution. I can just plug x in right here. So now if I do that, I get 3 times 30 minus 5y plus y equals 6. Now I need to do the derivative property. 3 times 30 is 90, and 3 times -5y is -15y. Now let me combine my y terms together to give me 90 minus 14y equals 6. Now I'll bring the 90 over to the other side and then subtract. 6 minus 90 is -84. So if we divide both sides by -14 now, we would get a y value of 6. So now to solve for y, let's replace y with 6 right here. So x would equal 30 minus 5 times 6, which is 30 minus 30, or simply 0. So our solution here is 0, 6. Now when you look at this system, nothing may jump out at you right away as to which method to use. So this might be a case where it's personal preference. You can do substitution or elimination. So I'm going to start with substitution. I see that the first equation, solving for x, can be done fairly easily if I just bring the -2y over to the other side. So now I can put that in the second equation to give me 4 times 2y minus 3 y equals 8. Now doing this derivative property, I get 8y minus 12 minus 3y equals 8. And then simplifying 8y minus 3y, I get 5y minus 12 equals 8. Bringing over the negative 12 over to the other side and combining that with the 8, I would get 5y equals 20. Now if I divide both sides by 5, I see that we get y to be 4. Now I'm going to plug that into the rearranged equation to find x. So x would equal 2 times 4 minus 3, which is 8 minus 3, which equals 5. Now let's just say that somebody else chose to do elimination. They noticed that everything was lined up, and then they could easily eliminate x by multiplying the first equation by 4. So what would that look like? Well, we would now have 4x minus 8y equals negative 12. Then I'll write the second equation directly underneath, and then subtract the two equations to eliminate x. So the x's cancel out, giving me negative 8y minus negative 3y, which is negative 5y. And then negative 12 minus 8 is negative 20. Now let's divide both sides by negative 5 to give us a y value of 4, which is the same value we got when we did substitution. Now let's solve for x by replacing y with 4 in the top equation. So we would have x minus 2 times 4 equals negative 3. Now simplifying that, we would get x minus 8 equals negative 3. And then solving for x, we would have negative 3 plus 8, which is 5. Once again, that's the same value we got when we did substitution. So now either way, let's say that the solution is 5, 4. Well, here's a case where there's roughly the same amount of workings. It was just personal preference as to what you like to do. So now that you have some suggestions to work with when moving forward solving algebraically, you can now move on to the next video in this lesson.